All right. Good afternoon, everybody. Happy Thursday. And here we are with another webinar in our Creo series focusing on the additive manufacturing extension for Creo. My name is Rob Romanowski. I'm the Director of Sales Operations for 3HTI, and leading our presentation and demo today is Zach Carson, who is a solutions consultant and applications engineer with PTC's Virtual Center of Excellence. Zach does quite a few demonstrations for us, and he's very smart, very knowledgeable, and I really appreciate having Zach on to help us out. So if you have any questions during the webinar, feel free to type them in. We'll try to answer them as we go. And without any further ado, pass it off to you, Zach.
Thanks, Rob. You're making me blush over here.
I'm good like
Yeah. So like Rob said, today we're going to be walking through additive manufacturing inside of Creo Parametric. Basically, the idea with this is develop designs, innovative designs, optimize your designs, and print them to a variety of printers, all from within Creo. We're going to start like we always start. If you've been on these before, some challenges that the industry commonly faces that Creo is going to address. Number one, we see this all the time. Design decisions now are always driven by manufacturing constraints and limitations. Engineers that are doing the designing really have to choose what they want to do and what they can do given the circumstances. So a lot of times that means being less innovative and making suboptimal designs because they're limited from a manufacturing perspective. High costs and lengthy lead times for development and manufacturing are something else that really cause a lot of problems in the manufacturing world. It means less revenue and potentially, hopefully it doesn't get to this, but dissatisfied customers as you're allocating more resources to creating tooling, jigs, etc., and then to actually to manufacture the products. We also frequently see designs that are just over-engineered. You might have to design a certain way because you have to be able to machine it, but a lot of times that's not the optimal design. Unfortunately, there's not really much you can do. Your hands are kind of tied if you're the designer who's doing it and you're working within your limitations. You're just limited by the processes that your company has. So PTC's solution to these challenges is Creo's Additive Manufacturing Extension, or AMX for short. It opens up a lot of new options for designers. You don't just have to do standard designing. You're actually able to do designing for 3D printed parts. So what do you get with additive manufacturing in Creo Parametric? It starts with lattices. This is one of the capabilities that are nearly impossible to do in traditional manufacturing, but it's a massive part of additive manufacturing. We want the designer to be able to use lattices, 2.5D lattices that basically are patterns that go straight through the model. You have 3D lattices, and the idea of the 3D lattice, or of lattices as a whole, is to take out a lot of weight, don't compromise strength, be creative, make it look really good, and also be a very structurally sound part. After you've created the lattice, maybe you want to try out some different ones, go ahead and actually use Creo's analysis capabilities to find the best possible lattice. You can integrate this with Creo, with the Creo's different simulation tools. So not just throw a lattice in there just to do it, but actually try different ones out, figure out what the best design option is, explore it, and come out with the best solution. Once you've got that, your design is done, you got to throw it on a printer tray. So you can lay out a single part, you can lay out nested parts, so basically just a print layout for multiple parts, and then figure out how everything's going to work. What's the optimal configuration? And once you find that, save this nest as a Creo assembly that you can manage and then easily modify just inside of the additive manufacturing extension. Okay. We also have what we call AMX Advanced. So this is all about metal printing. What this gives you is 3D printer connectivity to 70 to 80% of the metal printers on the market. Once you're connected, the integrated 3D print manager really simplifies printer selection and configuration. And this is doable thanks to Materialize and their build processor that we use inside of Creo Parametric. You also with AMX Advanced get rapid tray configuration. So there's built-in machine profiles and build configurations for supported printers, which are developed by Materialize experts and then even field tested for validation. And lastly, once your printer is connected, you got to build all of the support structure. It's a very important component of metal printing. So there's tons of options that you can configure for your specific printer right inside of Creo. You have standard configurations as well that you can just roll with, or you can tweak them to be exactly how you want. So Materialize Magic's SG Plus kernel is what's fully integrated with Creo Parametric. It even can act as a bridge between Creo and some other applications. That's really all that there is to it to introduce you to AMX. So with that being said, let's go ahead and get into the demonstration. Get into the good stuff here. For this demonstration of our additive manufacturing extension, we're going to be working with a design that we have of a Royal Enfield motorcycle. This is one, if you've been on these calls with us before, with me before, you might have seen this design in the past. But there's a couple areas of this that I want to focus on today. The first one is going to be the muffler and the exhaust system. So I can find it here in the bottom right. Let me just hide the casing real quick and then we'll isolate the front piece. But this is really where the sound attenuation actually starts, and it's what we'll be exploring AMX on. So I'm going to open this up, and essentially all this is right now is a solid piece with holes in it. It's something simple, but the idea is it's something we can really easily manufacture. And a lot of times that's the limiting factor in your designs. So if I cut through this, you can see the pattern that we're working with and really what the design is here. And we're going to use this just to provide us with the start of our exhaust system. So maybe we look at this design and we know it works, but you want to try something different on a particular bike, or now you have a 3D printer, you want to see what you can come up with that's more creative and more innovative than that simple design that we had. So let me just turn the center area off. And what we can do is, instead of doing that basic design, let's go ahead and throw a lattice in here. Right? Lattices are something that can be very complex and, as I said, almost nearly impossible to machine. But if you've got a 3D printer and a design tool, which is Creo, that can work seamlessly with it, then really it's not an issue at all making a lattice. So it's in Creo, it's a simple process. We basically just say, this is my area where I want to put the lattice. I want to put it inside here. So I define my boundaries. And then I can pick my cell shape. So what's the cell that I want this lattice to be utilizing in the space that I'm filling? And you can pick and choose, you know, the different parameters here for the lattice. It's all just using these little pop-up windows. So it's really easy just to come through here and select the different options, or identify, you know, the different criteria for minimum beam length or max beam length or ball diameter, you know, density, all these different things. You can use a lot of this just as is, but if you want to get specific, you can pick that criteria, and then whenever you're ready, go ahead and preview it. So based on what I came up with there, this is the model. This is what it would look like if I press OK and accept this thing. So this might make sense for us. This is kind of just a mess. I'm not going to move forward with it. What I'm going to do instead is go to something 2.5D. So not quite as complex, but a 2.5D lattice is something that could help us in this regard. I'm going to go with a hexagonal shape and just change some of the sizes. So lots of different options you'll choose when determining how you want your lattice to look. And in this case, I want to actually thicken the walls of this piece a little bit and round off the inside radii. So as you can see here, just you can get pretty specific with this stuff. And then at any point, just say, show me, preview, and then Creo will build that preview so you can look at it before you actually accept it. Another option you have is formula-driven lattices. So these are pretty cool, because really what the formula-driven lattice is doing, and what's unique about formula-driven lattices, is that they are going to minimize or even eliminate the need for support material. If you've never 3D printed, a lot of times you're going to need support material from the printer. It'll print your production material and your support material to actually hold up the 3D print. But formula-driven lattices really require almost none of that, if any at all. So they're very unique. You can get very specific and complex with how you want your formula driven lattices to look and what you come up with. In this case, something not too complex here that we can say is going to fill that gap. So this is going to let air through in a pretty unique way. Let's just say, for the sake of the example, this is something we do want to actually try out, so I'm going to accept it. And this is something that, if you wanted to, you would be able to, straight from here, take to a 3D printer. Creo, you can prepare it in Creo. You can do the printing optimization, set it up in the tray, do the slicing and everything, and even send it straight to the printer right from Creo Parametric. You also have the ability to take it to another system and do slicing there if you want to, and then send it to a printer. The options are there for you, but Creo gives you its own capabilities to create models that are or intended to be 3D printed. All right, so that's the lattice structure. That's really one of the main capabilities you get with AMX. There's also the actual printing of these parts. So let's say here, for this next portion of the demo, I already designed my lattice and my exhaust. Now I want to take the outer casing and I want to print an outer casing that's going to go over this engine. So on the bottom left of your screen, you see that cover there. This is what we're going to focus on. Just set that back to normal. Let's open up this outer casing that we're going to work on here. So this is actually, you'll see whenever we open this, the inside of this piece, it's pretty complex. This is something that even if you machine, it's going to take a long time to machine or cast, and then machine it down to shape. So instead, what we can do is just 3D print it, right? So what I want to do is I want to open that part up, and we're going to make some changes to it. So I want to give it, whenever we go in here, we open this cover and we start to prepare it for 3D printing. There's a couple things that I'm going to do. I don't want it to be the exact same thing as the one that I was machining before. So I'm going to give it more of a net shape, I'll say. Right, to get rid of some of these holes. Get rid of some of these features, change that hole. Just making it a little bit more simple. For these quick modifications, a nice way to do it is actually just to use flexible modeling. It's a tool that we have in Creo for doing some direct modeling. So if you want to come in here and say, modify an offset or remove some certain holes or do certain things like that, you know, that's really what we did here. I'm just kind of unlayering it and revealing the changes that I made using flexible modeling. And now with those all revealed and in display, what we can do is actually set this thing up to be 3D printed. So the first thing that I'm going to do is build a plane at the bottom, and I'm going to use this plane to determine my optimal build direction. And really, this is an issue of, if I just put this thing flat into my printer as is, I'm going to have support structure probably over the entire interior of this thing if it's facing down. Because if you have it over a certain angle, you know, you have to be able to put supports inside the 3D printing process, and then those have to be removed later on. So what I want to do is I want to analyze this model. I want Creo to tell me, hey, what's the best angle to print this thing? Or I can even put in my own critical angle in here. Let's say you'll know the critical angle you want to use, but I'm going to say for this one, I have a 45-degree print. I want it to be self-supporting. What's the best way to position the part? And you can let Creo calculate that for you. And that's what you can use on your 3D print. So it's one of those things where it can depend on the type of part, the complexity of the shape. Sometimes the optimal angle might be obvious. Other times with pieces like this, it's not even remotely obvious. So just like Creo, figure it out for you. Right, so what it's doing here is it's actually going in and trying different orientations. It's looking for what's working best. Then as it gets better and better and better, it's going to keep solving until it converges. And then the end result of that is very, very simple. It's just a coordinate system that basically says, this is your optimal build direction based off the critical angle for your self-supporting process on your printer. Right, that'll just come in as a Creo datum as part of this model, which you can see over in the model tree. It's actually called build direction. From this point, our model's good. We have our plane for our build direction. So now I want to take the model and I want to lay it out on a tray and actually start to build the support structures and prepare this thing to be 3D printed. So first step here, pick the printer I'm going to be using. It's just like if you were to print in Microsoft Word, you go to File, Print, Prepare for Print, then there's your printer list. And it's really easy to come in here and add some new printers. You just click the plus sign. You can look at the printers that you already have. These are, standard for some plastics and metals and so forth. All of the metal printers are, like I said, use the materialized build processor method. So you can get build processors for tons of different machines. And then right here in Creo, say, here's the machine, here's my printing envelope. And basically then how do I want to position this thing on the tray is pretty much the end of it. So once we got that set into the tray, this is where we can go in and use that build direction that we came up with. Okay, so I can come in here, generate support, edit support parameters. I already have a support structure profile for the demo purposes. You can see there's my self-supporting angle. So right now it's at 35. I need to change that. And at this point, all the stuff's been laid out. We can just go ahead and generate the support. So Creo was actually looking at this model. It's taking into consideration our critical angle. It's taking into consideration our build direction datum that we came up with. And this is it showing us the actual support material that's going to be required to print this thing. Okay. So this is actually the one with the 45-degree critical angle. The last one was the 35. It's just something different. You'll see differences here. And we just give it a minute to generate the support. And now for the one that I actually want to print, this is really what it's going to look like. So all of that black and yellow is support material. Like I said before, if you have this thing face down, that whole thing is going to be filled with support material. So this, in this case, minimizes the support material. And once I'm done with that, then I can actually take that into my print preview and look at the slices and tell Creo, build me a CLI file off of that support structure. Right. Again, the idea is I'm doing it all in Creo. This is a Creo print tray. It's a Creo assembly that I can keep track of and that I can modify. It's a design and printing environment all in one that works seamlessly together. So in this case, if you look at the top, you can see a lot of these, or you can see the model, and we can even display the slices on here. So you'll see that happening through the simulation. And really the key is you're getting all this intelligence, doing all the work on the Creo model. So you don't have it disconnected in different systems. You have the Creo model with all of the material removed for the secondary machining in our case. And then we can put it into a tray and we can print this out of plastic or out of metal, or even have Creo show the slices that we would need to actually do it. So let's just let this thing running or finish running through all the slices, and that's really going to be the end of it. There you go. So at this point, like I said a few times, we can do it all from Creo. Also, you have the option to design a model that can be 3D printed, take it to your own slicing software. That's totally fine too. A lot of people do that, and then just send it to the printer from there. All right. That's really Creo Additive Manufacturing in a nutshell. So I have a few more points I want to share with you to summarize how this can help you if you're not using it. Number one, additive manufacturing, believe it or not, we've seen it time and time again, is going to reduce your time to market. It lowers your overall learning speed and gives you the ability to make use of the 3D printers, whether they're plastic or metal. You can do it all in-house. You can come up with more innovative designs and get products out to the market faster. These are designs that a lot of times you can't possibly come up with or create on your own or with the manufacturing methods that you're using. And it's going to improve product quality and innovation. And that's really what everybody needs to do. The market's more competitive than it's ever been. You got to get products out there that are truly innovative and can't be manufactured using traditional methods that limit a lot of designers in coming up with creative ideas. And not only that, but you're not sacrificing quality. You might even be saving money and improving quality and reducing product cost that you're spending on prototypes and manufactured parts. It's going to help get products to the market faster, and then they're going to work better once they actually get to the field. That's what I had planned to go through for this demonstration of additive manufacturing in Creo Parametric. So thanks for coming, everybody. If you have any questions, feel free to shoot them in the chat.
Zach, great stuff. I mean, when you get into like the lattice structures, right? So, you know, it definitely using, there's purposes and reasons for using an additive approach for lighter parts. There's also another extension with that Creo uses called generative design, which we'll be running a webinar on soon. That's a really good one because it's similar to, you know, design for additive. It gives you all these different ideas. That's a little more intuitive, but without getting into that and talking to the point of additive manufacturing, as a company, 3HTI, we are also a reseller for desktop metal 3D printers. So if you are interested or want to know more about metal 3D printing, we can give you some advice and some tips in that respect, and also pricing and overall investment and what's involved, as well as for the Envision TEC line of printers that use a method of printing called digital light processing, or DLP, where basically there's an ultraviolet light that cures each layer of the resin material, and as it hardens, this process gives you a really accurate result in your model. So both of these types of desktop metal printers and the Envision TEC printers, which are owned by Desktop Metal, give you a very accurate part when it's done. And also Desktop Metal has printers for production as well. So if you want to know anything more in addition about 3D printing or 3D printers, we can definitely advise you there. And you can reach out to us by responding to the email invitation that was sent to you for this webinar, or you could email us at info@3hti.com. So I will have this webinar recording uploaded to our YouTube page by tomorrow and send this out to everybody so that you can watch this again at your leisure. And if you have any questions, feel free to reach out to us. And Zach, thank you again for your time today. And thank you everybody for being on. Have a great day.